Alright guys, let's take a look at 3.5, scatter plots and lines of best fit. So what we want to try to develop today or be able to do is to describe the relationship in a scatter plot between the X and the Y, the two data sets. And so if we look at some new vocabulary here that we're probably unfamiliar with, we have a positive, negative, and no association. And what we're looking to do is to kind of understand how one input changes or one variable changes as the other changes. So a positive association is going to occur when anytime our y value increases as the x value increases. So both of those data sets go up. And typically that shows itself, just like you would think, as a positive trend, just like a positive slope heading upwards as we read or run to the right. And then we have the negative association, which does just the opposite. Your y values are decreasing as the x values increase. So that negative association heads downwards. And then no association is just kind of scattered all over. So there doesn't appear to be any type of relationship between the two data sets. So you get points that are in the graph, some are high, some are low, and they're just kind of all over. And then a trend line is what we use to model that data. We're going to go ahead and pick 2 points. We fit this line to as many points as possible, and then we're going to find the equation in slope-intercept form of that trend line. And the sole purpose of doing that, the reason that we want to find the trend line, is so that we can try to understand some additional information about the data or to make estimations or predictions using that trend line. So let's look at some examples here. We want to compare the relationship between these two sets. So in this first example here, I have the hours after sunrise and I have the temperature. And I can see that after the sun starts coming up, 1 hour, 2 hours, 4 hours, 8 hours afterwards, I can see that my temperature is also increasing. So the X value here is going up and the Y value is increasing at the same time. So this definitely seems to have a positive association. If I looked at that as a line, as something that was linear, I can see that's increasing. That has a positive slope. So this is a positive association. And if I look at the next one here, the hours after sunset, so once the sun has gone down, as those hours continue, I see that my temperature is continuing to fall. It's decreasing over that time. Now that looks like a negative slope if I were to model that with a line, and that is a negative association. And our last example here, the rainfall after sunset, something that you would think wouldn't typically correspond or have a relationship. The hours after sunset, I can see that these are just kind of all over the place. So this has no association. Okay, so you can pause the video and you can try the 2 examples down below, A and B. Again, I can see example A here. As the X values are increasing, my Y values are also increasing. This is a positive association. And then the B value over here, excuse me, the B example, these seem to be kind of all over the place. As X increases, the Y values are high, they're low, just kind of all over. So this has no association. So now what we want to do is be able to come up with the values of the trend line. So in order to do that, we're going to take this data and we are going to try to model it with a linear function. So I'm going to try and place a line near as many of these points as possible. Okay, so I'm going to go ahead and try to, it doesn't have to start at 0, 0. It could come up here, it could be down here. Just depends on where it looks like it's going to best fit. So again, I want to try to come through or match as many of these points as possible. So every one below, I should have something above. And I'm going to say something right there is pretty close. So see, I have these pairings that are kind of one above, one below, about the same distance. And I'm trying to minimize that distance overall. So I just want it to fit to as many points as possible. Now I'm going to pick 2 points on that line, and it looks like that's probably a pretty good one right there. So that's going to be 6, 200. And then let's find another one. This one right here looks pretty good. So that's going to be 16, and it looks like we're 3, so 54, that'd be 500. So now we're going to find the equation of that line, and we've done this several times before. First thing I'm going to do is use my slope formula. And I'm going to go ahead and plug in my values. So 500 minus 200, that's 300. 16 minus 6 is 10. So this has a slope, it looks like right about 30. Okay, so now I found my slope, so I'm going to write the rest of the equation. So I want slope intercept, mx plus b. So I've got my y, m, x, b. And we'll start subbing stuff in. So the slope I found was 30. I'm going to go ahead and pick the smaller point down here, just smaller numbers, easier to work with. And I'll start substituting. So I pick the x and the y from this corresponding point, use those to represent the x and the y in this equation. I'll use my slope of 30. And now we're going to solve for b. So 30 times 6, 3 times 6 is going to be 18. So 30 times 6 is 180. And then we just subtract. And there's your b value. So the equation of my line in slope-intercept form is y equals 30x plus 20. Okay, let's look at another example of that. Again, what I want to do is I want to try to model this with a line as best I can. So something right about there. I'm going to select 2 points on this line. That looks like a pretty good one right there. That's right at 4 and 66. And that looks pretty good. That's right at 9 and 58. So in general, I can see that hours after sunset, again, we talked about this one in the temperature. This is decreasing. So as x increases, the y decreases. That's a negative association. And so we're going to model that with the trend line here. So first step, again, is I'm going to find slope. And that's y sub 2 minus y sub 1 over x2 minus x1. So we'll go ahead and fill in those values. So 58 minus 66 over 9 minus 4. So that's going to be 58 minus 66. That's negative. That's going to be a 8. And 9 minus 4 is going to be 5. So I get a slope of negative 8/5. And we'll go ahead and set up our equation. Mx plus b. We'll identify our known quantities. I just found slope. It's negative 8/5. I'm going to pick one of these points. I'm going to take the smaller, easier numbers to work with. 4 and 6. There's my x. 4 and 66. And my y. And then we'll substitute. Okay, so this one doesn't look like it's going to work out quite as nice. That's okay. So I have negative 8/5 times 4. Well, negative 8 times 4 is going to be 32, so that's negative 32 fifths plus b. And to solve this, then I just add 32 fifths. And we'll bring it over here. And so 66 plus 32 fifths. Well, 32 fifths, 5 is going to go into 30. How many times? Let's see, 5 goes into 30. 6 times, and then we've got 2 remaining. So we'll add that 6 to the 66. So that's going to give us 72. And then 2 of those fifths remaining. So there's my b value, 72 and 2 fifths. Okay, then we can write the equation of the line. Y equals my slope, negative 8 fifths, plus 72 and 2 fifths. Okay, let's take a look at another example here. Be the last one, and in this one it tells me the table shows the amount of time required to download a 100 megabyte file for various internet speeds. So we're going to assume the trend line continues. How long would it take to download a 100 megabyte file if the internet speed is 75 kilobytes per second? So we're given some data. We're going to go ahead and put that onto the table here, and we'll just plot these. So I get 35 and 6.65. Now the way this is arranged, it's going from 0 to 10, 0 to 10. That'll work here, which is going to be the download time. That's going to be my y. And then down here, okay, we're going to have the internet speed. That'll be your x. And so I'm going to go ahead and make all these times 10. So this is going to be 10, 20, 30, 40. Okay, so we're just going to scale all these up and just multiply them all by 10. So at 35, so 35, that's somewhere here right in between. We're at about 6.65. So somewhere between, just a little bit above the halfway point. Right about there is fine. 40, I'm at 582. So at 40, I go to 5 and 0.82, so not quite to 6. 45, I'm at 517, so just a little bit past 5. And at 50, I'm at 465, a little bit more than halfway. 55, I'm at 423. And at 60, I'm at 388. So maybe somewhere right up in there. So what we want to do then is we're going to go ahead and model this with a line. And I'm going to adjust that a little bit. Okay, and we'll go something maybe right in there. Now I need 2 points from this line in order to model it. So I'm going to pick 2 points. I want pretty good points to work with. I'm going to go ahead and take 10 and 9 right there. And then see if I can come up with another good one. Well, it doesn't go through any of these nice hash marks, tick marks anywhere again. I'm going to go ahead and take this point right here because it looks pretty dead center. So that was at 60, and that was 388. Okay, so again, first thing we're going to do is we're going to find the slope. So I take the difference of my y values, difference of your x's. Okay, so we're going to go ahead and find the slope here. So I've got my difference of y is 3.88 minus 9, and I have 60 minus 10. So we'll use the calculator on that, and we'll say 3.88 minus 9. That is negative 5.12. Over, and then we'll say 60 less 10 is going to be 50. So we'll go ahead and divide that by 50. And we get negative 0.102. Okay, so there's your slope. So now we're going to go ahead and find the equation. So y equals mx plus b. Let's go ahead and identify our known quantities. Solve for the unknown. My b is negative 0.102. I'm going to go ahead and take the x and y values from right here. Those are nice, 10 and 9. And we'll go ahead and substitute. Now let me erase that. Got a little squished in there. Negative 0.102 times x. I'm sorry, I miswrote the y. That's 9 coming from there. And then plus b. Okay, so let's go ahead and a little simplifying here. Negative 0.102 times 10. Okay, so let's go ahead and adjust that. So multiplied by 10, that's going to move the decimal 1 point, so negative 1.02. And then plus b. And to solve, I'll just add that. So I get 10.02. Okay, so then the equation for my line here is y equals my slope, negative 0.102 plus b. Okay, so the numbers weren't as nice, but the process is just the same. We're going to model this with a line. We're going to pick 2 points on that line and then substitute it into the slope-intercept formula so that I can find the equation. Now the last thing here is it asks us about the x-intercept of the trend line. And it wants to know, is it possible in a real-world situation? And actually, I apologize. Let's find one more thing. This asked me originally to determine or interpret what would happen at x equals 75. So let's go ahead and find that real quick. So what that is, we'll do that over here to the left, is we're going to go ahead and use this trend line that we just found. This is the whole point. This is why we do it. And we're going to determine what is the speed at 75 kilobytes per second. So we're just going to go ahead and crunch those numbers. That's an input and an output. And we will go ahead and take negative 0.102. Multiply that by 75. And to that we will add 10.02. And we should be right about 237. And that's talking about the download time. So it looks like that is minutes. And if we look at our line here at 75, I should be somewhere right about 2.3, 2.4. And we're right about there, so we're pretty close. Maybe our line's a little low. But again, it's just an estimation tool in order to help us estimate where we would fall within that trend. And the last one here, the x-intercept of the trend line. And it wants to know if that's possible in a real-world situation. So what we're looking at is the x-intercept, so where this crosses the x-axis, and it looks like it's somewhere here between 90 and 100. Well, is that possible? So what we're talking about is the speed of the internet and the time at which it takes to download. So the X-Intercept is going to be some speed, say this is 9.5 maybe, and then 0. So your Y value, what's important here to understand is your Y value is 0, and Y is talking about your time, which is essentially saying that it would take no time, not very quick, not a blink of an eye, not an instant, but actual 0 time, not measurable. It wouldn't take any time. It would be instantaneous to download something at that speed. And we know that in the real world, that's just not possible. So we'll just say there must be some amount of time needed to download. So having 0 time is just not possible. Okay, make sure you get your notes filled out, and then we'll get some more practice.